cruise line that we were with, and it like that doesn't count because that's like their island. Norwegian, I think it was.
We went on Royal Caribbean this summer.
Yeah. Most of the cruise lines have bought an island, and they just have a private island out there
It
somewhere.
was too hot. We left after a while. My sister was like, she dumped her head in the water.
Yeah, I like the heat. And then we went. We were gonna go snorkeling, but then it was really expensive, so I just had goggles with me, and we just went snorkeling without snorkels. So essentially, you just have to keep coming up and breathing, as opposed to like having a snorkel. Homework, please make sure it's in the plan book. And now it's going up here. And now we're coming over here. Alright. I feel like you guys listen to me way too much. So anyone want to read like this entire screen starting with earlier? Quinn, you are always reading. Let's try. But I always pick you. Like, I remember I always pick you. Let's compare this.
Earlier in this course, we worked with proportions such as x equals x over 8. One way to begin solving a proportion is to eliminate the fractions and create an equivalent equation. When you eliminate the fraction, it is easier to solve. Fraction elimination is not just for primes, however, it also applies to proportions. Two other equations with fractions. In this lesson, you will learn how to eliminate fractions in equations. Then you will be able to use what you learned about solving equations.
Alright, so if we solve, let's go ahead and write on our paper, 3/5 equals x over 8. And there's a reason that I don't want to go any further. And if you have a book out, awesome. First off, kudos to you. But if you do, please don't actually read ahead. Please stick with us because I kind of want to like release certain info and have us all doing the same thing at the same time. So if you had this, what would you do? I need to use cards to make sure that I'm talking with everybody because I feel myself coming back to the same people over and over. So Quinn, your card is on top. What would you do if you had that proportion, 3/5 equals x over 8?
I would times 5 and 8, and now times 24. Wait. Yeah, I would times 5 by 8, 8 by 5, and 3 by 8. And then whatever the answer to...
Well, I like what you're saying, but you're ruining my activity right now. What you're saying is true, but you're ahead of me, and now I'm sad.
Oh, I'm sorry.
According to my poster, what would we do here? Like the third poster in there above the drummer dude, what do we do to figure out a proportion? We can always, now some of your teachers probably called it the butterfly method, but we can always cross multiply. So while what Quinn is saying is true, 100%, probably going to come back to you later. We here, back with what we used to know, would say, okay, 8 gets multiplied by 3, that makes 24. 5 gets multiplied by x, and now I don't have fractions. Right? Now I got rid of the fractions that are involved in my problem. So please write that down, draw those circles. Or some people, I think some teachers had you like drawing lines that connected them. If that's what you got used to in 6th grade, you can do like the connecting lines. And if you want to make your work look good, I would put this below the proportion, but I don't have space. I should really move this up onto the TV, but I'm worried it's going to show you guys too much. And then we can solve it from there, right? To get x by itself, we would do what? Because x is stuck with multiplication of 5. What would we do to get x by itself? Anybody?
We add 5 and x.
Ooh, not add. We gotta divide, right? I'm trying to get my smart board down here. So if you have now 24 equals 5x, we gotta divide, right? To get rid of this multiplication that x is stuck in. And if I do it over there, I gotta do it over here. And we can write that as mixed. Right? How many 5s in 24? 4. And 4/5 left over, right? 4, like, because if I think about 20 and 4. But now we're going to start to involve decimals. Now, there are always multiple ways to do things. such as Quinn just exemplified by giving me a method that is obviously true, but not what I was thinking he would say. So Hannah, oh, I hate that Zoom. Let's talk about this. Hannah has this equation: 400ths x plus 1 equals 2.2. 400. So please write this down. This is 5-10. For those of you playing along, how we should be. Now, Hannah's a hater. Now, it's okay. She doesn't hate people. Hannah hates fractions. Hannah also hates decimals because they're essentially the same thing as fractions. And Hannah's very upset by this problem because there's a 100th place decimal and a 10th place decimal and then a 1. So Hannah thinks to herself, like, okay, I could rewrite this as fractions, but I hate that idea. But if I think about it, it's 400ths. Right? Now, you don't have to write this method, but it might be real helpful here in a minute. So it's 400ths times the x, right, plus the 1 equals, 2 and 2/10. Or really, I could make this 22/10 if I want to go ahead and make it improper. But like you said, Hannah's a hater. And she wants to destroy these fractions and or decimals. She wants a problem that is the same problem, but no decimal places and no denominators, right? So no fractions. I want you to talk with your group and decide what could we do to rewrite that equation, not solve. Like, I don't want you to solve for x. How can we rewrite that equation not using decimals or division? What could we do to both sides to destroy all that? I'll give you like 90 seconds to a couple of minutes. Just want you guys to think about this. I heard this idea, which is true, that then the denominators match. I'm not saying that's the right way. I just heard that idea, and it is true. You have your math side first day or sweet. I'll have to eat over here and I will get that. No! Hannah hates it.
Wait, you said we can't do it.
I didn't do it.
No, but
No division.
What do you think?
You were doing division. Aren't fractions always division?
exactly.
Kids say things like that.
We said we can't 5 times that.
Fractions are divisions in themselves.
Yeah, and we hate division because division doesn't really exist. Which actually, Braylon, we could argue that that's actually not division, it's multiplication by 1/100th. Not 1/100, but 1/100th. And then it would be multiplication. Alright, George has a bombshell idea here. George, what's your idea?
Okay, my idea is to multiply everything by 100. Multiply everything by 100. And if I want, I could write it as 100 over 1. But if I do it on one side, I got to do it on both sides. Which this 100 destroys that 100. Because same numerator denominators will delete out to 1. So that becomes 4x. Be careful, this is where people screw up. That 100 multiplies by everything. So this 1 becomes 100. Don't like that, that's writing in green. And then this 100 deletes this 100. Now, if I had not made this 100, I'd have a little bit more math to think through. But before you multiply by the 100, if I think through making this 100, it's perfect, because then that becomes just 200
20. That just wrote me green. So then solve this with your team, and I bet it's real easy. Marley, what do we do first here? We could, but that actually will be slightly harder than if we take a different choice first. Here's why. So I want to talk about what Marley said is true, but then I'm going to jump over to Simon and see what you say. If I take Marley's route, fine, I can. I could divide this by 4 and divide this by 4, but I also would have to divide this number by 4, which isn't always easy. Here it would be. 100 can divide by 4 pretty easily. But I can't always trust that that number will work well with the division that I need to do. So, Simon, what's your suggestion? Yeah. First, we could get rid of that 100 in case it wouldn't work nice in the division. That gives us 4x equals 120. Hopefully we all thought this through. If not, please make sure you're getting it written down right now. Then, Marley. Yeah, I was about to say, essentially say what you just said. By the way, great job last night. I was definitely scared. I watched Marley at gymnastics last night, and she does the uneven bars. And if you can watch that and not be nervous that they're going to hit something, like Marley's pretty tall, right? So especially when you're on the low bar, I was like, because her feet are so close to the ground, like that would hurt. It makes you on the high bar, and then I'm just like, you're really high up and you're upside down. Well, I got some cool pictures, so if you want to see them, I got to get them uploaded to the computer. What's 12 divided by 4?
3.
3, then put the 0 on. Sorry, I wrote it right, but I'm not rewriting. Questions? Try this. In these problems, work with your team, A, B, C, D.
Oh my god.
Here, I'll just bring them down and make it real big for a minute, and then I'll copy them over. Now, don't write these all down and then start solving. Write down A, and then solve it vertically, like going straight down beneath it. Then do B. Or you could write A, and then off to the right, write B. Off to the right of that, like leave yourself vertical space to solve these. Which is why I can't solve it on this screen, because there's no vertical space here. So I'm going to move those up onto the TV and then make some slides for these. So this is 5-11.
Well, I work together.
Please make sure our conversations are on topic. Some of these might not need any weird multiplication work first. And then, oh crap, fractions.
I don't need to. First.
Be careful with your signs. I'm going to give you a few minutes to work through these. I want you guys to check your answers with each other. Even if you don't solve them together, I want you to check your answers with each other. By the way, reminder, I got some people with things still out for me, whether it's in map or not in map yet. If you have something to turn in, please try to remember to do that today. How, so I can get a gauge, how many of you are going to Stone Lab? Gosh. Take half my class could be there. If you have a very strong suggestion or really good idea of something that you would like to do on Monday or Tuesday, like if you would like to instruct something to your class, teach something on your own, my idea in the back of my head is that I'm going to have my buddy Devin come in, who leads our Go Club out there, and he would teach Go to all my math classes. So like every seventh, well, except for Mr. Hall's kids, but we could actually pick those up at some point. My idea was then, like, when the Stone Lab people come back, we could teach you guys, like your peers can, and then everyone would be able to play, which is actually a really simple game to learn, but really complicated strategy. The game itself is really easy. It's just this board, or a bigger board, and black and white stones. That's it. Easier than chess, easier than checkers. Well, probably as easy as checkers. But the strategy is where you start to like get into some complex ideas. So if you have any other ideas kind of like that, whatever, I'm trying to figure out what to do Monday, Tuesday. But for those of you going to Stone Lab, you probably won't miss content, especially with this class that moves so fast. I don't like to, like, if half the class is going to be gone, I don't want to move forward. Yeah.
I have a good idea. Can we play poker?
No. I cannot. Let it officially be known in a recorded format, I am not going to encourage playing poker to seventh graders. Now, this also comes from, like, if I had asked my grandma if we could play poker, she probably would have, like, washed my mouth out with soap. She thought those games were, like, the devil. Seriously, my grandma was old school. She passed away a couple years ago, but she, like, so I don't know what your parents are cool with, whatever, but this is an ancient game that's been played for thousands of years that people don't gamble on. It's just like a mental workout. So that's why I was thinking we'd do that. Potentially. But hey, I'm talking, talk to me later. You should be solving this equation.
Yeah, you know how bored these songs. Yeah, you're talking with the physics of this chair, which I can appreciate. And physics is fun, but you have a task right now. Right? And he's going to trust you to complete the task. I have no. I was tired.
I'll talk about that later. But really, part of it's just puberty. Your body's using a lot of energy right now.
Unless we multiply by 100, but I don't know.
Either way,
Wow. Well, because we
That's fine. You can multiply by more than 10. Now, all because you took a different process. I want to reiterate, when I have you guys like trying to check with each other and everything, there are many right ways to get to Florida. You're all trying to check, did we get to the same place? Don't tell somebody they're wrong because they took a different process. Compare your results. Compare your answers. So one way that we can start here is to multiply by 10, but you could multiply by a bigger number on both sides. If I want to get rid of the decimal places, just guys, come on, be honest with yourself. Portions make numbers harder to deal with. If I can make all my numbers whole values, or like integer values, entire numbers, it's easier. This makes it epically easier. And pretty soon you'll get so good at visualizing this, you can just like copy the problem down, already multiplied by 10, or already multiplied by 100, like, without decimal places and things like that.
start with the original.
Guys, I cannot state it enough how important it is to start with the original equation that's in the book or on the test or whatever you're looking at. Write down your original. If you write it down a step or two in, if you've already done stuff in your head, you are just begging to start making mistakes as we get into harder and harder concepts. Write the original first. Trust me, if you don't understand how the kinesthetic part of your body, what you actually do and physically move, connects with your brain, come talk with me. I will convince you why it matters, but writing down the original, activates your brain. I have this plus that equals that. Come on. You got this.
So wait, could you simplify? Could you divide by 10 and then
Okay, can you not freak out if I make another announcement?
No.
Because I like you guys being able to anticipate what's happening. We talked about potentially doing tests because this is the last section we need to cover in this unit. We talked about starting a test tomorrow, Friday, whatever. I'm debating pushing that till after Discovery Days because next week is pretty much shot with Stone Lab and Discovery Days. But my concern is we won't practice this for a week and a half, right? Because I would plan other activities for tomorrow and Friday, but so I need to see that we are engaging and practicing these things now to try to get these things solidified. So if we don't, and then we take a week and a half off, it's gonna be no good. Okay, so and it might be even longer than that because we wouldn't have the test on Monday. Right, we would come back and probably start the test on Wednesday or Thursday of that week, so it's going to be 2 weeks. You wouldn't have to practice this because you wouldn't be with me. So please engage with this now in class so you can catch your mistakes. Mistakes are a good thing. Mistakes are an amazingly good thing. Mistakes are how we have almost every invention that we have. I forget how many times, the Bell, whatever his name was, who tried to invent the telephone. Yeah, Alexander Graham Bell. He has hundreds of phones that don't work. Right? It didn't do what he wanted it to do. Then he figured it out. The light bulb, tons of light bulbs that didn't work, or they exploded, or something bad things happened, and you learn from it. Now, if you get the gas inside of it wrong, if the filament gets too hot, so you have to think about old school light bulbs. I mean, it's just electricity passing through a wire, and it gets heated, so it becomes bright. Here, once we do the division, what is x in A? 8. Sorry, especially if I'm just asking for an answer, it's really just anybody. Any questions on A's process? You could have multiplied by a bigger number and gotten even bigger numbers over here. That could have worked.
What did you eat?
Hmm?
What got A?
What do you mean, what's that? Are you just trying to make a joke? Because I will let you help me with this one if you want.
Okay.
So, Quinn, what do I do here?
So, first of all, you want to add 200. Well, no. You want to add negative 250 to negative 400.
So, Quinn is taking the addition approach, which I love, because it makes things easier over here. Because there's not really any subtraction, but a different person might say, subtract 250 to make this 0, which works. It makes sense. But over here, then that's a little bit more complicated than saying, hey, bad guy 400 plus another bad guy 250.
He's a traitor.
We get super bad guy.
Who's a real villain?
Some people like to put their negative slightly higher than what a minus symbol would be because it helps kind of activate your brain that that's a negative symbol, not that you're subtracting. And then, what do I do to finish this?
You want to take 650 and divide it by 100, which gets you 6.5, negative 6. Well, and then you want to convert it to a negative number, because otherwise the final answer would be negative. So technically,
division by any amount, or sorry, any multiple of 10, 100,000, 10,000, 100,000, you just move your decimal as many places as you have zeros. So if you want the shortcut, we have 2 zeros here in the division. We bump the decimal 2 places, and that's how it ends right there when it started up here. Even though we didn't have a decimal up there, quote unquote, it exists, right? It is where it is. We don't have to show it. George?
So for when you do 400, if you did negative 400 minus 250, would that
Minus still tells us go down.
Yeah.
Right? So it's a weirder thing to think about, because if we try to think good guys, bad guys, and here's like that discussion that I'm having on online with another teacher that I'm trying to help. You can't take away a positive 250 from negative 400. There aren't 250 positives to take away. But I can add more negatives to it. I can always put more things into the situation. So I try to think about it physically. I don't have positives to take away, but I can put in more negatives. Now, if you can remember in your head, subtraction tells you go down, whether you're positive or negative, like so I'm kind of referencing here, positive or negative, like subtraction's always telling us to go down, unless it's take away bad guys, and in that case, we get more positive, right? So it's hard. I'm never going to tell, like, honestly, multiplication's easier. Addition, subtraction is weird because the positives and the negatives.
So, who is the real bad guy of this problem?
I don't know. Probably me, since I'm making you guys do all this stuff.
Oh.
Here, Connor, you want this one?
Yeah, well, I didn't really simplify it. I just found a way to solve it.
Okay, what was your way to solve it?
I just how 30, 10. How to get 30 from the fraction of 3, which is 90.
Ah, okay. So can I show that a slightly different way then? I think I'm with what you're saying, but correct me if I'm wrong. So you said 90, like you got your right side to 90, and I believe how you got there
Over 3.
was multiplying by 3. Like, stick with me for a second and then correct me if I'm wrong. Because if I do that, this destroys, right? They, like, top, bottom, same, get out of here. So then, this is 2x equals 90, right? 30 times 3. But then, I don't want the 90 actually, because that's twice of what I want. So,
I did over 3.
I know. So, I'm going to show both ways. So, we would then have to divide by 2, and we'll get to 45, right? But, what Connor's saying is 30 is 90 over 3, right? 90 divided by 3 is 30. So, if Connor says 2x over 3 equals, crap, I got to write this correctly. Can't apparently hold the eraser today. If both sides are divided by 3, just get rid of it. Right? If it's doing the same thing on both sides, this is the same as saying 2x equals 90. Now I could show the work to get there by multiplying each side by 3, and really you can make it 3 over 1 if that helps your brain. But like, he got to the same place. And he took a different route, because in my head, I would have to think multiply by 3, get 90, then divide. But it works. It's perfect. Whatever works in your brain. I love that that's how you saw it, that this is 90 over 3, and you kind of put them both over 3. Questions on this? 2 different ways, actually a lot of different ways to solve it. Another one that is actually the ultimate shortcut. Anybody know how to get x by itself in Uno's step? No. Let's do purple. How do I get rid of a division by 3? Multiply by 3. How do I get rid of a multiplication by 2?
Divide by 2.
The 2 and the 2 destroy each other. The 3 and the 3 destroy each other. I get just x. Now, x is 90 over 2, which I could write like that, or we can rewrite it as just 45. If you want to completely get rid of the entire fraction in one step, multiply by its reciprocal. right? Flip it, that's its reciprocal. If you multiply by that, you're going to get 1. Because remember, this is really 1x. We don't have to write the 1 because I don't say 1 Braylon or 1 Octavia. Like, it doesn't make sense. We're not redundant like that. And D, didn't mean to do that. Here, what is the thing that Hannah, our hater, is opposed to? What does Hannah hate? Actually, Gwendolyn, help me out. What does Hannah hate here? Yeah, so here, what makes the fraction? It's a division. Yeah, division by 5. So how do we undo that or fix it? Wait, what? How do we get rid of the fact that there's a fraction here? Don't start trying to solve it. Make Hannah happy first. You just told me what makes it a fraction. Division by the 5, right? That's what's making a fraction here. Undo that. Do the opposite. Multiply by 5. Right? So if Hannah wants to destroy this division by 5, she multiplies by 5. That gives us just x. Right? Because the 5s both get out of here. Sorry. Plus 5 equals, what's on my right side? Negative 30. But then you're already at the answer, Gwendolyn. If I subtract 5 from both sides, or add a negative 5, ooh, careful. Negative gets more negative. And that's why we don't like saying subtraction. Right? So, Braylon, you fell in the trap that everyone falls in. 30 doesn't get smaller. Well, it depends on how you think about smaller. Negative 30 gets more negative. Which actually takes us, Braylon, please fix this on your paper. You had 25. At least I thought that's what I heard. It goes to negative 35. Because it gets more negative. You have these down because you're pretty much just playing. As long as you have these down and you're done with them, you're okay. Otherwise, I need you in your best. Okay. Any questions from A through D?
None.
Going once.
There's a question.
Going twice.
Wait, someone has a question.
Chloe. So when I multiplied by 5, it all depends on what process you took. When I multiplied by 5, this 1 became 5. Right? So this multiplication distributes to both things inside the parentheses. So it distributes here, but 5x over 5 just makes x. And it distributes to here also, which is why I have that 5. But if I take a different order to solve all this, laying down some beats, I could take away this 1 right here. And that would actually take me to negative 7. Right? Which then I still have x over 5. Hannah's really mad, but we just told her to calm down and go to the corner or something. But now we get rid of the fraction by multiplying by 5. And check it out. We get the same answer. Another way to floor out. Maybe you went to see Aunt whoever on the way. Aunt 35. You went to see Aunt additive inverse. Or inverse operation, I guess would be more accurate. Alright, so when we look at 12 now, check out 12. Now, you don't really have to take their process like little step by little step. If you can jump straight to what you think they're going to try to do. We want to make Hannah happy in this problem and get rid of the x-thirds fraction and the x-fifths fraction at the same time. Is our end goal. What could we do to get rid of both of those denominators at the same time? Now, if you can't think of anything, if your team can't figure it out, work through ABC. I'm going to give you like 2 minutes to do this, and then we'll come back together.
You know.
Why did the teams never work?
That's a great question.
Stop with
At a minimum, this should be written on your paper. Olivia, this one's going to come to you. I'll give you a little bit more time, though. Wait, why are you trying to add fractions? Don't do that. That's hard.
But it's not that hard.
But it's hard.
But
No,
Hannah
you said it's not
hates it.
that hard. You didn't say it wasn't hard. It's
Hannah hates it.
Then do it.
now, Braylon,
Yeah, I agree.
you're talking about adding fractions. Now, before we would be able to add fractions, what would we need to do? Braylon, I don't care now. I'm talking with you. Right. Which, haha. So, Hannah would still hate this. But then we would have the common denominator. But, to make Hannah happy, not Hannah hate her, we could get rid of that common denominator of 15, which we're going to have to do eventually. So, what ABC here walks you through is if I want to get rid of this 3, I multiply by 3. If I want to get rid of this 5, I multiply by 5, or do it all at once. Which then gives us 15x over 3 plus 15x over 5 equals, gotta do it over here too, 15 times 10 is 150, 15 times 6, 30, 60, 90. So this becomes 240, and that's honest to God how I do my multiplication. I break it. Oh, we'll throw some finger snaps in there. This now becomes 5x. This becomes 3x. And, well, 240 is still 240. Guys, I don't make things up for you. I'm honest that last night, Dave, my friend who also teaches middle school now, but he used to teach 4th and 5th grade, we're having a very heated discussion about stacked multiplication not helping your brain whatsoever. Because then you have to like add this 0 on and bump it over and carry this thing and like it's just complicated. You love it because you learned it. But if you had never learned that method, broken up multiplication makes a lot more sense to say 15 times the 10. It's the same thing. Like you're doing the same thing, but it makes more sense for your brain. And then 15 times 6. But then we can add the x's. Hannah's happy. After we divide, what do we get? X is 30. Those same skills that we just practiced with both the fractions and the decimals would carry through as we did problems like this. I lost it. So here, what would we multiply everything by to destroy the 7 and 3 at the same time? 21. Here, what could we divide by to destroy the denominators? 10 would work. Here, 18 would work, but 6 is easier. 6 is easier. Down here, oh, that's a tough one because the 3, 4, and the 5. 10 doesn't work. Ah, that's a tough one. I will tell you for sure 120 would work. Because now we got to get out of here, so you should start packing up. But 3 and 4, right, 3 and 4 make 12, and I know if I put a 0 on, it would be divisible, but 60 would also work. Alright, get out of here, guys. Have a wonderful day.
Yay!
30 would not work because the 4. 12 would not work because the 5. Right, it's got to be a multiple of all 3 of them.